Now let's take a look at the IEEE 802.11 Wireless Local Area Network Wi-Fi standards. And we'll do that by looking at the table you can see here. Now, in the 802.11 protocol standards, the first one that came out was the 802.11 1997. And this came out in June of 1997. The frequency range was focused at 2.4 gigahertz, and the bandwidth was 22 megahertz. The stream data rate was 1 or 2 megabits per second. The next one that came out was the 802.11a and b, and these were released in 1999. Now, the 802.11a is capable of 5 gigahertz and 3.7 gigahertz. Their bandwidth is 20 megahertz, and the data rate increasements are really what are interesting. They are able to go up to 6 all the way up to 54 megabits per second. The 802.11b works at the 2.4 gigahertz, which is the same frequency band as the 802.11 1997 version. Now, here the bandwidth is the same, the 22 megahertz, and the data rates in the original 1997 version, it could only go up to 1 or 2 megabits per second, but in the 11b standards, you could go up to 11 megabits per second. The actual data rates are 1 megabits per second, 2 megabits per second, 5.5 megabits per second, and 11 megabits per second. And these were like the standard stream data rates. Now, going down to 802.11g, which was released in 2003, this operates at the 2.4 gigahertz range and uses the same 20 megahertz bandwidth. The data rates would enable you to go up to 54 megabits per second, just like the 802.11a standards. Now, more recently in 2009, the 802.11n version came out. And this used the 2.4 and the 5 gigahertz range. And basically, you could go up to much higher data rates. You could reach up to 72.2 megabits per second, or you could go up to 150 megabits per second based upon which frequency band you were using. Well, if you were using the 2.4 or the 5, and the available bandwidth would determine the maximum data rate that you could go up to. There's more. The future standards were coming out, and they would use something, they would enable us to go to even higher standards. And the best representative of that is 802.11ac. The AC devices, these modem chips, are actually on your smartphones if you purchased a smartphone in 2014. Now, typically, the frequency range is at the 5 gigahertz ISM band, and based upon the bandwidth, you could go up to 96.3 megabits per second, or now reaching into the hundreds of megabits per second speeds, 200 megabits per second, 433 megabits per second, and even a remarkable 866.7 megabits per second, almost there, reaching the gigabits per second range. Now, we don't have this yet, but soon we will, which is 802.11ad. And this is going to come in 2016. Now, the frequency range is the 60 gigahertz frequency range, so it's extremely high. And the characteristics at these high frequency ranges are they are influenced by shadowing effects. These signals cannot penetrate through walls or any type of solid object. So you need to be in direct line of sight with the other communicating device. But the bandwidth is extremely large at these high frequencies, which is 2.16 gigahertz, and that enables us to go up to 7 gigabits per second of a data rate. A little bit more, and this talks about demodulation and more, which is the focus of the range. What is the approximate communication range? Once again, the IEEE 802.11 wireless local area network is for local area network applications. That's like a business space, your home, or some type of office area or library area that is limited in range. So the range is actually very important because this determines how we can use it and what is the most effective way to provide services, and also how many access points do we need to install in a certain area. So taking a look at these standards, well, the 1997 version typically had an indoor range of approximately 20 meters, outdoors about 100 meters. 802.11a, typically you could reach at the 5 gigahertz frequency up to about 120 meters. At the 3.7 gigahertz range, you could reach much longer distances. Now, 802.11b for indoor is like 35 meters, outdoors is like 140 meters. And the 11G standards does approximately the same as the 11B because they're at the same frequency range and they typically use the same bandwidth characteristics. It's just their modulation structure can be a little bit different. Now, based upon what you see here, now these ranges, this does not mean that if you go the maximum distance, you're going to get the maximum data rate. No, it's not like that. The maximum data rate is provided when you're closer to the access point. The further away you are, if you're reaching at one of these limit distances, then you will not be able to get the maximum data rate. So the data rate will decrease based upon distance. It's just that these are the maximum distances that you can go and still receive some connectivity. But once again, that is not guaranteed. Now, for the 802.11 wireless local area network standards, let's take a look at the 11N, 11AC, and 11AD standards. The frequency ranges are, of course, 2.4 and 5 gigahertz ISM bands. Now, for 11N, this uses OFDM with MIMO of 4. And the range in indoors is up to about 70 meters. For outdoors, it actually reaches over 200 meters. Now, for 802.11ac, which operates at the 5 gigahertz range, this uses OFDM MIMO 8. And the indoor range is around about 35 meters. The outdoor range is a little bit hard to determine. For 802.11ad, which will come in the future, this is using the 60 gigahertz frequency range. And because the frequency range is so high, the typical propagation distance is much more limited. So, like I said before, we get much higher data rates at much closer ranges. Typically for indoors and outdoors, around about 10 meters. Now, for 802.11n and .11ac, they use the MIMO devices, MIMO technology, and as you can see, the asterisks on the modulation part, we have MIMO 4 and MIMO 8. And what this means is that this represents the allowable MIMO streams for each technology. And a MIMO 4 and a MIMO 8 would typically use the multiple antennas at the transmitter and receiver side to increase the data communication throughput. And that's what these devices are doing. Now, Wi-Fi uses the ISM band, and we need to know about this because this influences the characteristics of our communication network. ISM stands for industrial, scientific, and medical, and it's used for these major purposes. It's an internationally reserved band, and it's for these purposes which these are not going to be licensed. However, there are regulations on how you can use the signal in these frequency ranges. Devices using the ISM band will experience interference from other products operating at the same frequency band. This is unavoidable. Now let's take a look at some of the ISM bands. The ones that we have here are shown, and they show also the bandwidth, the center frequency, and also the availability. Is it local or is it a global worldwide frequency band that is reserved? And as you can see, the focus of our Wi-Fi devices are down here, the 2.4 gigahertz band, and also up here at the 5.7 gigahertz band. And these are the worldwide bands that are used. And that's what we are using for our Wi-Fi devices. Now, Wi-Fi interference, for example, at the 2.4 gigahertz range, this includes many other types of devices that use this frequency range as well. For example, if you heard about Zigbee or 6LoWPAN, they use the IEEE 802.15.4 modem. and they operate also at the same 2.4 gigahertz ISM band. So naturally, they would have some type of interference. Microwave ovens, Bluetooth, baby monitors, cordless telephones, amateur radio equipment. All of these work at the 2.4 gigahertz range, and they are going to result in some type of interference to our Wi-Fi devices. Now, there's another technology called dual band. And unlike ordinary Wi-Fi equipment that only supports to use one single band at a time, dual band has the capability to transmit both on the 5 gigahertz and on the 2.4 gigahertz band simultaneously. So, in other words, at the 5 gigahertz band, you can be using 802.11a, 11n, 11ac, and also at the 2.4 gigahertz band, you could be using 11b, 11g, and 11n. And an example of this would be like to do something like this. So if the access point is capable of dual band services, then you could use like the 2.4 gigahertz band for email or to surf the web. And for the wider bandwidth, the more throughput can be provided through the 5 gigahertz ISM band. So we'll use this to do like streaming high definition video and play online video games. There's another technology called Wi-Fi Direct, and devices can connect directly to one another without the access of a traditional network. It's something similar to a more advanced ad hoc mode. Devices can make a one-to-one connection, or a group of several devices can connect simultaneously. Now, with optional services, users can send files, they can print documents, they can play media services, and display screens between and among multiple devices. Another Wi-Fi feature is tethering, hotspots. Now, this refers to connecting one device to another. In the context of mobile phones or internet tablets, tethering allows sharing the internet connection of a phone or a tablet with other devices such as laptops. For example, let's say that I have my hotspot tethering capability turned on, then my Wi-Fi station can connect to the internet by connecting to a smartphone using Wi-Fi. In other words, you can see a device is connecting to the smartphone through Wi-Fi, and the smartphone on the other side is turned on its cellular mobile communication network and connecting to a base station. Now, so through the smartphone, the other tablet PC device can directly connect to the internet through the tethering smartphone. And that's what this capability is. These are the references used for this part of the lecture. If you need more information, I recommend you to look at these good references. Thank you.